The Pythagorean theorem works with any triangle that has a right angle, that is a 90-degree angle. The side opposite of the right angle is the hypotenuse. It is the longest side of the three-sided triangle. The other two sides of the triangle are just referred to as sides. So the hypotenuse is always opposite the right angle, and it is the longest side. The Pythagorean theorem is a squared plus b squared equals c squared, where c represents the hypotenuse. The hypotenuse is, in this example, the red line opposite the 90-degree angle, and it's associated with the number 5 in this case. So side A could be either the yellow side or the green side, it wouldn't matter, and side B could be either the yellow or the green, just so long as they're not the same sides. If you square the value of side A and the value of side B, it will equal the value of side C squared. You have to square all these. So let's give you some examples. We have 3 squared, which equals 3 times 3, which is 9. We have 4 squared, which is 4 times 4, which is 16. And we have 5 squared, which is 5 times 5 equals 25. The squared value of sides A and B are 9 and 16. You can see them because of the orange around them. If you were to add 9 plus 16, it would equal 25. So if you only knew the value of 3 and 4, you could calculate that to be 9 and 16, and then you would add that, it would give you 25. Then you get the square root of 25, and that gives you 5. Here is a recap of the first problem. We have a squared plus b squared equals c squared, where c is the hypotenuse. In this case, it's 3 squared plus 4 squared equals c squared. So let's just say we don't know what c is. So we take 3 squared, which equals 9, because 3 times 3 equals 9. 4 squared equals 16. So 9 plus 16 equals 25. The square root of 9 is 3, the square root of 16 is 4, the square root of 25 is 5. So our answer is 3 squared plus 4 squared equals 5 squared. From this we know that the hypotenuse is 5. The second example is more tricky. If the hypotenuse is 10 and one side is 8, what is the remaining side? So you have a squared plus b squared equals c squared. So you have a squared, which equals 8 squared, plus b squared. You don't know what b is, and you know what c is, which is the hypotenuse 10 squared. So 8 squared is 64, 10 squared is 100, and your equation comes to 64 plus b squared equals 100. So how do we find out what b squared is? Because that's the purpose of this problem. One thing we can do is we can subtract 64 from both sides of the equation, and so long as you're doing the same thing to both sides of the equal sign, it still remains equal. In other words, if I were to add 500 to the right side of the equal sign and 500 added to the left side, it would still, both sides would be equal. In this case, I'm going to subtract 64 from both sides of the equation. This still makes them equal. So here we have b2 plus 64, which is the original equation, minus 64 equals 100 minus 64. Remember, we're subtracting 64 from both sides of the equation, and that makes them equal on both sides. So plus 64 minus 64, they cancel each other out to 0. And so that leaves us with b squared equals 100 minus 64. When we subtract 64 from 100, it equals 36. So now we know that b squared equals 36. The square root of 36 is 6, because 6 times 6 equals 36. So the answer is 6, because 8 squared plus 6 squared equals 10 squared. We found out the value of b squared, and that is 6 squared. Let's do a couple more problems. In this problem, find the length of the hypotenuse, or side C. In this case, it's represented by the letter x. So one side is 12, one side is 16. What's the value of the third side, the hypotenuse side? We plug in the formula. 16 squared plus 12 squared, the two sides, equals x squared. 16 times 16 equals 256. 12 times 12 is 144. We add those together, it gives us 400. 400 equals x squared. If you were to put in your calculator 400 and then get the square root would be 20. So the answer to the question of what is the value of x, or the hypotenuse, the answer would be 20. And that makes sense. When you compare the sides, 20 is very reasonable. We can see the answer is 20 in the first problem. Let's try the second problem. The hypotenuse is 41. It's the longest side. One side is 40. What is the length of the remaining side? It's going to be a considerably smaller number. It's a smaller side. How would we do this problem? We start off with the standard Pythagorean Theorem formula. A squared plus b squared equals c squared, where c is the hypotenuse. And plug in the numbers. One of the sides is 40, so we put in 40 squared plus b squared, we don't know that value, equals 41 squared, the hypotenuse squared. 40 times 40 is 1600, plus b squared equals 41 times 41, which is 1681. Now, if we subtract equal amounts from both sides of the equal sign, it's still, both sides remain equal to each other. So let's subtract 1600 from both sides of the equation. You can see those numbers in blue. 1600 minus 1600 equals 0, which you end up with just the value of B2 equals the value of 1681 minus 1600. $1681 minus 1600 is 81. So now we have b squared equals 81. And we need to get the square root value of 81. Well, 9 times 9 equals 81, so that will give you the square root value. So if you plug in the numbers, you can see that it works. 40 squared plus 9 squared equals 41 squared. And so we know that the answer to the question is 9. If one side is 40 and another side is 9, the hypotenuse would be 41. We know that if the hypotenuse is 41 and one side is 40, we know the other side is 9. And that answers the question. Thank you.